Today we should talk about double angle and half angle formulas. Okay. For this, recall we have seen this formula before in the previous lecture. Sine of alpha plus beta is equal to sine of alpha multiplied by cosine of beta plus cosine of alpha multiplied by sine of beta, right? Anna, welcome. We just started. We are talking about the double angle formula first, then we will talk about the half angle formula. All right, this was the formula for the sine of the sum of two angles, right? That we saw before. I know it by heart, I have memorized it, but in case you don't remember it or you wanna make sure that that's the formula, I show you that in our worksheets, in our website, right, we have this sheet is an important sheet, the unit circle sheet, and on the bottom, it comes this formula, right? In the bottom, you can find this formula for the sine of the sum of two angles. Where is that, Professor? Here. Sine of x plus y equals sine of x multiplied by cosine of y plus cosine of x multiplied by sine of y, which is what I have here, right? This formula, you have it there. Great. Okay, very good, guys. So now turns out if we manipulate this formula cleverly, we can figure out a formula for the sine of the double angle. You will see. If you consider alpha and beta to be equal to theta, then since this formula is true for any values of alpha and beta, in particular, it should be true for the case where alpha is equal to beta, right? Let's say they are both equal to this angle theta. Okay, so then one thing we can do is this. We can write here instead of alpha theta, instead of beta theta. So here we will have that this should be equal to sine of alpha, but we're saying that alpha is theta, cosine of beta, but we're saying that beta is equal to theta, so cosine of theta, plus cosine of alpha again, cosine of theta, sine of beta, sine of theta, right? So now notice theta plus theta is just 2 theta. The double angle comes up, right? And these two guys added, look, sine of theta multiplied by cosine of theta is the same as cosine of theta multiplied by sine of theta, right? This is due to the community property for multiplication. So these guys are the same. So I can say that this, since this is 1 times sine theta cosine theta, 1 time cosine theta sine theta, this is 2 times sine theta cosine theta, right? Very good. And these guys, what you see here is called the double angle formula for sine. Okay, so this, and I strongly recommend that you memorize this formula, is very useful. It's called the double angle formula for sine. Double angle formula for sine, okay? It tells you what is sine of twice an angle, right, for sine. All right, very good, very good. It's a very nice and useful formula. You're gonna use it a lot in calculus 1, calculus 2, okay? Sine of 2 theta is equal to twice sine of theta cosine of theta. Very good. All right. Similarly, mathematicians play around with the formula, the general formula for the cosine of the sum of two angles, okay, which is this, cosine of alpha multiplied by cosine of beta. Remember, it's counterintuitive. You expect plus here, but turns out it's minus. Then sine of alpha multiplied by sine of beta, right? I have memorized this formula, but in case you don't remember this formula, when you're doing your homework, you're taking your exams, go to our website or in Blackboard, go to important sheets. There is this so-called the unit circle sheet. And that in the bottom shows this formula. Where is that, Professor? Here, cosine of x plus y, cosine of alpha plus beta, cosine of x, cosine of y, cosine of alpha, cosine of beta, minus, look, the plus goes with minus, right? Minus sine of x, sine of y. All right, it's there. All the formulas are there. All right, great. So now, since this is true for any value of alpha, any value of beta, in particular, should be true for the case where alpha is equal to beta, right? So let's represent that with angle theta. So this should be true. Cosine of theta plus theta, right? We're calling alpha and beta theta equal to cosine of alpha, but we're saying that alpha is theta. Cosine of beta, saying that beta is theta minus sine of theta again, right? Great. This sum, theta plus theta, 2 theta, the double angle appears there, right, for cosine. Now this guy, cosine of theta multiplied by cosine of theta is equal to cosine square of theta, right? Cosine square of theta minus sine of theta times sine of theta, sine square of theta, right? And this is what mathematicians call the double angle formula for cosine. Okay, double angle formula for cosine in its first form. Turns out 2 more forms can be derived. I will show you. But for now, this formula that also I strongly recommend you to memorize is called the double angle formula. Double angle formula for cosine. Okay, very good. Form 1, let's call it form 1, okay, because there are 2 more forms I will show you. Now, if you have this formula and you use the Pythagorean identities, you can derive 2 more versions, 2 more forms for this formula. How? Recall that from the Pythagorean identities, we shown that sine square plus cosine square of any angle is equal to 1, right? Is equal to 1. From here, I can isolate cosine square by subtracting sine square of theta in both sides here. And I'm gonna get the following, that cosine square of theta is equal to 1 minus sine square of theta, right? I get this. But now, if you replace this cosine square of theta for 1 minus sine square of theta here in this equation, right? Then we're gonna be able to get a new form for this formula. Cosine square, remember, 1 minus cosine square here, right? The 2 is gonna come up soon. Minus sine square of theta, right? But remember, this guy has an invisible one here, this has an invisible one here. So minus 1 sine square minus 1 sine square is minus 2 sine square, right? And minus 2 sine square of theta. And there you have another form for the cosine of the double angle. So let's call it double angle formula for cosine form 2, okay? Form 2. Great, second form, right? Turns out there is a third form. And then I will tell you why these 2 forms, those 2 extra forms are good for, okay? There is a third form. Suppose now, instead of replacing cosine square, you replace sine square for what you get when you manipulate the Pythagorean identity. Look, from the Pythagorean identity, which is this, sine squared plus cosine squared equal 1. If I now subtract cosine squared in both sides, what would happen? What will happen here? 0 sine squared equal 1 minus cosine squared, right, of theta. Now, if you replace this sine square that appears here in this formula, right, for this 1 minus cosine square, look what's going to happen. Look, this is going to be cosine square of theta minus sine square. But I'm going to substitute sine square for its equivalent in terms of cosine, this 1 minus cosine square, right? So if you do the math now, this will become cosine square of theta minus 1 minus times minus plus, right, plus cosine square of theta. And finally, you're going to get this new form, cosine of 2 theta equal, look, there is invisible one here, invisible one here, 1 cosine square plus 1 cosine square, 2 cosine square, right in blue, 2 cosine square of theta minus 1, right, minus 1. And this, guys, believe it or not, is the third form, okay? This is going to be the third form, double angle formula for cosine, form 3, okay? Now, you may say, right, Professor, you gave us the first form, the second form, third form. Why? Why did you add these two forms? Well, notice, guys, that the first form depends on cosine and on sine, right? The second form depends only on sine. So you need only sine to compute this cosine of the double angle formula here. The third formula depends exclusively on cosine, so only need cosine, right? So according to what you have, right? Let's say they give you sine of theta, then you may use this formula, right? They give you cosine of theta, you may use this. They give you both, maybe you can use this. So it will be up to you, right? But there are 3 formulas, and these 3 formulas together with the double angle formula for sine, they are all in the unit circle sheet that you have. I'm going to give you the link, the straight link, if you want to hear. It's very important, this sheet for your copy link. Let me put in the chat. It's on our website, but also here directly, okay, if you want. All right, so where are they, Professor, those double angle formulas? Here. See? Double angle identity, sine of 2x, 2 sine x, cosine of x, right? And they give you some additional forms that we'll talk about that later. Cosine of 2x, they give you 3 forms. The first form, cosine square of x minus sine square of x. Second form, 2 cosine square of x minus 1. Third form, 1 minus 2 sine square of x, right? The 3 forms are there. And then this I will add later. Okay, guys, so formulas. We have now 1, 2, 3, 4 formulas, right? We can work with. So let me show you how they work. Let me give you an example here, and then we will go over tangent, okay? Yeah, so example here, let's go to our worksheet. I'm gonna do the first one, and then I'm gonna show you I'm gonna ask you to do the second one, okay? Okay, there you go. So suppose they say that cosine of theta is minus 5/13, and they tell you that your angle theta is in quadrant 2. They ask you to find sine of 2 theta, okay? How we proceed there? Well, first we start by writing out the formula for sine of theta, right? The formula for sine of theta. Sine of theta, we know, we just showed that 2 theta, right? Formula for sine of 2 theta. which is being asked, right? Sine of 2 theta is equal to what? 2 times sine of theta cosine of theta, right? Yeah, and we show where to find it in the worksheet, or if you memorize it, will be even better. Sine of 2 theta, 2 times sine of theta cosine of theta. Great. Now, as usual, identify what you have and identify what needs to be found. What do we have? Cosine of theta here, right? Cosine of theta is given, so this is given. But sine of theta, in order for me to calculate this, sine of the double angle, is not given. I have to find it, right? Sine of theta must be found. All right. So now, then let's do it, right? Let's do it. So they say that theta is in quadrant 2. So let's represent our angle in quadrant 2, right? Somewhere here. Here is going to be our angle theta, right? Quadrant 2. Now, remember, when the angle is bigger than 90 degrees, we work with its reference angle, right? The reference angle, remember, is the acute angle formed by the terminal side and the x-axis. Is this small angle, right? We call it theta prime. Work with that angle. Here, form a triangle, right? We're gonna work with this angle here, theta prime. Focus on this triangle. Okay, so we're gonna work there. So now they're saying that cosine is 5/13, right? Remember, cosine is adjacent over hypotenuse, right? So adjacent should be 5, hypotenuse should be 13, right? In this triangle that we made up. We don't have this guy, let's call it A, but it can be found using the theorem of Pythagoras, right? A squared plus 5 squared is equal to 13 squared. A squared plus 5 squared, which is 25, equal to 169, which is 13 squared. You can check in your computer or in your calculators, right? A squared subtracting 25 both sides equal 144. So A square root of 144, A equal 12, right? A equal 12. When you have A equal 12, right away, place it here, A equal 12, right? A equal 12. So I'm gonna write here that A that we're looking for is just 12. It's just 12. A 12. Great, right? Came from here. Theorem of Pythagoras. All right, now that you have completed your triangle, then we can find this guy, right? This sine of theta, this sine of theta we can find. How? Well, first, go ahead this way. Sine of the reference angle theta prime is equal to opposite 12 over hypotenuse 13. Now the sine of theta, the one I'm looking for, right, for my formula, should be in value the same as the sine of the reference angle, right? But the sine might not be the same, right? We have to check the sine with this nice mnemonic device that we have. All students take calculus. According to all students take calculus, what do you think? Anybody could tell me what should be the sign, positive or negative? The sign of the trigonometric function sine, positive or negative? According to all students take calculus on the second quadrant. Someone posting something on the chat. Positive. Very good, Gabriela. Excellent, excellent, right? I think you have mastered the use of all student take calculus mnemonic device. Positive because sine and its reciprocal cosecant positive. So this one positive, definitely. And mathematicians, when the sign is positive, they don't write, right? So it's 12 over 13. Great. So now, yeah, we found this guy, right? We found the sign. So now we go back to our formula and we say, okay, now we can complete the computation because we have all the ingredients here for our formula, right? So sine of 2 theta will be just equal to 2 times sine of theta that we just found, 12 over 13, multiply by cosine of theta that was given here, right? Be careful with the signs there, guys. Now you will get finally your sine of 2 theta, right? How? Put this in your Desmos scientific calculator, right? Or multiply using partial computation, doesn't matter. All right, using our Desmos scientific calculator, let's compute it, right? 2 times 12 over 13 times minus 5 over 13, right? And this is what the calculator shows by default, but I show you, right, that convert it to a fraction is this, right? Which is the same, multiplying this times this is 60 times 2, 120 here, and 13 times 13, 169 if you want to do it manually, right? But I'm giving you this option because some computations in the homework especially will be complicated. So use this tool to convert this to a fraction. Very good, guys. Minus 120 over 169, right? So minus 120 over 169, which makes the answer this guy, right? Very good. Can you try the next? I will leave this for you to have as a reference, okay? Try to do on your own this guy, the number 2. It will help you a lot on your homework and on your exam also, okay? Try to do number 2. Maybe I can give you some hints. Maybe the formula, right? Yeah. Let's write out the formula here. Sine of 2 theta equal 2 times sine of theta cosine of theta. This is how it starts, right? And then you have to identify what we have, what you don't have, right? What you have to find. So here clearly we have sine now, and instead of finding cosine as we did before, we have to instead of finding sine as we did before, we have to find cosine, right? So find this cosine using this triangle, and make sure you are following this, right? The angle is in quadrant 4 now. So when you draw your angle in standard form, you have to place it somewhere in the 4th quadrant here. I'm going to help you giving you this diagram, okay? The angle is big. It's very big. So we have to work with the reference angle, right? So work with this theta prime. Yeah, we'll do the work there. Construct a right triangle there. I'm going to shade it, and then you have to continue with this. Yeah, so work in this here, this triangle. Right? And recall that sine from SOHCAHTOA is opposite over hypotenuse, right? Yeah. So your opposite is going to be 4. Your hypotenuse is going to be 5. Find this base using the theorem of Pythagoras and then continue, right? Aha, I see some activity on the chat. Yeah, Gabriela, you made my day. Excellent, excellent. Yeah, very good. Excellent, excellent. Very good. Yeah, it's not that difficult, guys. You have to follow the method, right? And figure this out. Very good, Gabriela. Let's do it together, right? We are supposed to find the base B here. That can be done using the theorem of Pythagoras, right? B squared plus 4 squared equal 5 squared. B squared plus 16 equal 25, and subtracting 16 in both sides, or of both sides, better said, this is 9, B square root of 9, B equal 3. When you have B equal 3, put it here right away, right? We found B, the base 3. Therefore, we completed the triangle, right? Here, so we can find any trigonometric function really now of theta via this reference angle. So how that works, Professor? Well, you start like this. You are looking for cosine, right? To complete your formula here, to be able to compute your formula. So you start by writing cosine of theta prime, cosine of the reference angle. What is that? That is adjacent 3 over hypotenuse 5, right? Over hypotenuse 5. But from there, we can say that cosine of theta will be numerically the same, right? Numerically the same is a property, right? To the cosine of the reference angle, but the sign may change. But anyone here could tell me what should be the sign of the cosine function using this mnemonic device all students take calculus? Is it positive or negative? Look, see here in the fourth quadrant, right? Is it positive or negative? Yeah, think about it, right? According to all students take calculus, the function cosine, is it positive or negative on the fourth quadrant? Gabriela, excellent, excellent. Positive, right? Positive. Excellent, because the letter C means that cosine, right? Cosine and its reciprocal cosecant, secant, cosine and secant, they are positive. So cosine is positive. So this one positive again, right? So with all student take calculus, you find the sign. Now that you have cosine of theta, now we should be able to compute this sine of 2 theta, right? Sine of 2 theta should be equal to what? 2 times sine of theta, right? That we just we were given, right? Sine of theta is this minus 4 over 5 times cosine of theta. Cosine of theta, we found it right here. Cosine of theta, look, is here. We found it. Positive 3 over 5. So 3 over 5. And put this all in your scientific calculator. I strongly recommend you use the Desmos scientific calculator. 2 times negative 4 over 5 times 3 over 5. And we get this in decimal form first, but we can switch it to fractional form, minus 24 over 25, right? Which is the same as multiplying 3 times 4, 12, times 2, 24 there, right? 5 times 5, 25, right? But I'm just giving you this extra tool in case the numbers are not friendly, right? Yeah, use this, guys. Don't get stuck. Especially in your homework, perhaps you have to do it. So minus 24 over 25. And that's it. This is the answer. This is it, right? Excellent, excellent. Very good, guys. So you see how you can use the sign of the double angle to solve this problem, right? Great. All right. So now there's another one here for cosine. So let me explain this to you, how to use now the cosine formula, right? Which turns out to be easier. You will see why. It turns out to be easier because we have more forms for this formula, okay? That turns out to be easier. All right, so let me explain this number 3 for you, okay? And then we will talk about tangent. Sine of 2 theta equal negative 4 over 5. Theta is in quadrant 4. Find cosine of 2 theta. Cosine of 2 theta. All right, so we need to figure out what is this cosine of 2 theta, right? And fortunately, we have 3 forms for this, right? 3 forms. I'm going to bring them up, the 3 forms here from the unit circle sheet, right? For you to see. And you're going to tell me which form do you think we have to use, right? There are 3 forms here, 3 forms here. And you're going to tell me which one we have to use. According to you guys, look, you see the 3 forms here, right? Cosine of 2x, cosine of square of x minus sine square of x, cosine of 2x, 2 cosine square minus 1, and cosine of 2x, 1 minus 2 sine square. Which one do you think we should use for this? We are looking for cosine, but we are giving only sine. We are giving only sine. So out of these three, which one should we use? Let me show you here. Look, we have three formulas right here. Three formulas here, three. The first one, the second one, or the third one? Someone is commenting. Number three. Paul, yeah, Gabriela, excellent. The third one, right? Number three, the third formula. Because the third formula requires only the function sine, right? And this is what is given here, only sine, right? So we're gonna use this guy, okay? This form. Very good. You're gonna get 1 minus, right? 1 minus 1 minus here, it's wrong here, 1 minus 2 times sine square, right, of theta, that version. Why? Because we have this guy, so we just have to replace it here, right? So cosine of 2 theta will be 1 minus 2 times sine squared minus 4/5 squared, right? So look how quickly we can get this. We don't even need the information about the quadrant. We don't need to do what we did before, right? And all because we have this special form. So -2, -4 squared is 16, 5 squared 25, right? We just have to do this. Now, how we do this? First, I'm gonna do it manually, and then I'm gonna show you how you can get this on using your calculator, right? 32/25, right? 2 times 16. This one is 1/1 times 25 here, LCD, right? 25 here, right here, LCD equal 25. So this will end up being this cosine of 2 theta equal 25 minus 32. 25 minus 32. What is that? Well, -7, right? So -7/25. Okay, -7/25 is the answer, which is this, right? Now, guys, we are closing up, right? We're getting ready for our exam 3, for our final. I want to give you tools, right? Suppose this way is too long for you to get the answer, right? How can you get this faster using our Desmos Scientific Calculator? Well, one thing you can do is this. You type this whole thing in your Desmos Scientific Calculator, right? 1 minus 2 times 16/25, right? Very good. You get by default the decimal answer, right? But you want the fractional answer, right? Convert to fraction, so -7/25. You see, guys, right? So in case you have difficulties working this out, if the numbers are not friendly, use this tool, okay? Don't get stuck. At this point, you need to use all the tools that you have. All right, great, -7/25. All right, one way or the other. So you can see the fact that we have more forms for the formula help us here, right? So to avoid going through this strategy. Sine, unfortunately, has just one form, so you have to go through this. But for cosine, you may avoid. All right, there's another question here where we have to find cosine of 2 theta. Oh, this is backwards. Yeah, I'm going to talk about this. But before, we have to go back to yeah, this is cosine of theta. Yeah, the half angle formula. Let's go back to the lecture and let's talk about tangent of twice theta. Okay. Yeah, right. Let's do this. All right. So suppose, not suppose, let's recall the general formula for tangent of alpha plus beta, right? That is tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta, right? You may memorize this formula, but if not, you have the option to go to the unit circle sheet. Is there. Where is this formula, Professor? In the bottom here. If you look at tangent, here, the bottom, right? Look, tangent of x plus y equal tangent of x plus tangent of y, follow the signs on the top, divided by 1 minus the signs on the top must be followed, right? Tangent of x, tangent of y, right? Is this formula. Great. But now, this formula is true for any values of alpha and beta. Suppose alpha and beta are the same, right? It should be also true. So suppose alpha and beta are equal to some angle theta. Then we can say alpha is theta, right? Beta is theta. So tangent of theta plus theta should be equal to tangent of alpha, but alpha we're saying is theta, plus tangent of beta, beta we're saying is theta, divided by 1 minus tangent of theta multiplied by tangent of theta, right? All right, so now theta plus theta, 2 theta, okay? Tangent of theta plus tangent of theta, 2 times tangent of theta. Right, the sum of these two is this. Now, 1 minus tangent of theta times tangent of theta multiplied by tangent of theta, tangent is square, the square of theta, right? There you go. This is what is called the double angle formula for tangent, right? Double angle formula for tangent. So this is good formula, very useful. Double angle formula. Double angle formula for tangent. Okay, very good. Now with this formula, then you can use it to reduce some expressions. You can use it to do some calculations if needed, right? It's a useful formula. It's for the case when they ask you to figure out the tangent of 2 theta. Now, notice there is a relationship between tangent of 2 theta and sine and cosine. Tangent of 2 theta should be sine of 2 theta divided by cosine of 2 theta, right? If you manipulate this as sine of 2 theta over cosine of 2 theta using the previous identity, there is a way to relate this formula with the previous ones, with especially these two and the first one too, I think. And what is that, Professor? Well, mathematicians figure this out and they are all here in case you need them, right? In case you need them. In the unit circle sheet, again, if you go to the bottom, you will see that, for example, sine of 2 theta can be expressed also besides this as 2 tangent of theta plus over 1 plus tangent square of theta, or sine of 2 theta. And similar for this version of cosine of 2 theta, you can have 1 minus tangent square of theta, 1 plus tangent square of theta, right? It comes from combining the first 4 formulas that we got with a third one, right? And also here, in case you needed cosine of 2x, it's just the reciprocal of tangent of 2x. So if you have tangent, you can just flip this, right? So this is another extra version in case you need it. All right, so this is for the double angle formula. Let me show you the last example so we can go over the half angle formula, okay? There is an example here, number 4, where they are asking you to do something tricky. Let me explain this to you. They are saying here, okay, cosine of 2 theta is equal to 5/9. Figure out what is cosine of theta. It's kind of the problem backwards, right? Drawing backwards. And this kind of will serve us to as an introduction to see that it is possible to find the sine of half of the angle when you have the given angle, right? How? Well, notice that this guy has a formula, right? I'm looking for cosine. So we have three formulas. So we have, remember, right? For cosine of 2 theta, we have cosine square of theta minus sine square of theta. We have 2 cosine square of theta minus 1. And we have another one. This one is 1 minus 2 sine square of theta. Notice I'm looking for cosine, right? This is what I have to find. So clearly I should use this formula, right? The second one, because this contains the cosine that I'm looking for. So right here, 2 cosine square of theta minus 1 equal to this, right? All right, great. We have that, right? Now solve for cosine of theta, right? This equation. I'm gonna do that together. Okay, so we have this, right? Adding 1 to both sides of the equation. Get here that this is 2 cosine square of theta equal 1 plus 5/9. Again, right? If you use the LCD of 1 and 9 is 9. 9 times 1, 9 here, plus 5, 14/9, right? Cosine square of theta. And dividing both sides by the number 2 here, we will get to isolate our cosine square of theta, right? Cosine square of theta is equal to what? 14/9. Remember, when you divide by a fraction, we end up flipping the fraction and multiplying, right? So times 1/2. This is 14, this is 18. Sine of theta, 14/18. Simplify, 7/9, right? Take square roots in both sides. Cosine of theta. I don't know which one should be, right? The positive or the negative square root. We don't know, but we will know once we apply all students take calculus. I will tell you what the sign is there. According to all students take calculus, what should be the sign? Well, we see this will be a square root of 7/3, right? Square root of 9/3. But the sign, they say that theta is between 0 and pi/2. Then theta in Q1, right? Quadrant 1. So it should be positive, right? Positive. So this is it. So then we get this, and this is it, right? Very good, guys. Very good. So you can see that somehow we went from an angle to half of the angle, right? It's possible, right? By solving for cosine of theta, this formula, right? So if you do this in general, it is possible to come up with a formula for half of an angle. This is an example, right? I did it here from scratch. So this should be sort of a background to justify that there are formulas for the half of the angles, right? Half of the angles, and that's what I'm going to show you next. Okay, so going back to our lecture, let's talk about half angle formulas. Turns out, if you do what I did with that problem that I just showed you, right? But in general, right, you can develop or derive this formula. you can derive that the sine of alpha over 2, half of an angle, is equal to plus minus. Remember that plus minus appears because you take a square root of both sides, right? Plus minus a square root of 1 minus cosine divided by 2. Okay, this is the first formula. This is called half angle formula for sine. That's right here on the side. Half angle formula for sine. Good. Then for cosine of alpha over 2 plus minus the square root of 1 plus. It's very close to this one. 1 instead of minus, just plus. 1 plus cosine of alpha divided by 2. This is called half angle formula for cosine. Okay. Now, dividing this component wise, right? Dividing this here, sine over cosine gives you tangent, right? The division of these two after eliminating number 2, you keep the radical is this, right? 1 minus cosine on the top, 1 plus cosine on the bottom, the square root of the quotient, plus and minus. This is called half angle formula for tangent. Yeah, feel free to memorize this formula, very useful. But if not, they are all here, guys. There's even the half angle formulas. I have placed it here in our unit circle sheet. Half angle identities, look, you see them here, right? Sine of x over 2 is this one, the first one. 1 minus cosine of alpha. Cosine of alpha over 2 is here. 1 plus cosine of alpha over 2, and tangent of alpha over 2, 1 minus cosine over 1 plus cosine square root. This is an extra formula if you want extra forms according to what you are doing, okay? Feel free to use them. All right, so now application of this formula, right? Application of this formula, how you apply these half angle formulas. Yeah, I added the 2 versions that I showed you in the worksheet here, right? Equivalently, this half angle formula for tangent in terms of sine and cosine, half angle formula for tangent of in terms of cosine and sine with in a different form. All right, example. Find the exact value of sine of 15 degrees. Sine of 15 degrees. Exact value, right? Meaning show radicals if there are radicals, show fractions if there are fractions. Okay. Avoid the decimal form, right? So what should be sine of 15 degrees, knowing that 15 degrees is half of 30 degrees. All right, let's see. Sine of 15 degrees, knowing that it's half of 30 degrees. Well, one thing we can do this, right? We can say that sine of 30 degrees over 2, using my formula, right? The one that I have here, it will be equal to what? Plus minus square root of 1 minus cosine of 30 degrees, right? Over 2. And using this formula, right? This formula with alpha equal 30 degrees. Very good. Half angle formula for sine. Very good. So now let's work this out algebraically, right? Algebraically. So what this should be equal to? Well, plus minus what? Don't worry about the plus minus. In the end, I will tell you what to do to determine if it's plus or minus. Cosine of 30 degrees. Remember, cosine of 30 degrees is, I know it by heart, square root of 3 over 2. In case you want to make sure that that's the cosine of 30 degrees, guys, you have the unit circle, right? Always handy. In there, it will appear. Look, 30 degrees is here. Look at the first coordinate. This is always cosine. The second coordinate is sine, right? Sine of 30 degrees, 1/2. Cosine of 30 degrees is square root of 3 over 2 is there. All right, great. Now we got to do this algebra, okay? Carefully here. Look, we're going to use the LCD and stuff. this will be 1 is the same as 1 over 1 minus a square root of 3 over 2. LCD of 1 and 2 is 2. So we multiply this by 2, right? So in order to get that done, and don't forget there is a 2 on the bottom. All right, plus minus what? This is going to be 2 minus a square root of 3 on the top, right? On the top, over what? Over 2, and this fraction divided by 2. But remember, guys, 2 is the same as 2 over 1, right? So dividing a fraction by another fraction is the same as multiplying this fraction by the reciprocal of this fraction, right? Yes, so you learned this in previous courses, guys. So 2 minus the square root of 3 over 2 times the reciprocal of 2 is 1/2. And there you will have this plus minus square root of 2 minus the square root of 3 over 2 times 2, 4, right? 4. But now, taking the square root of a quotient is the same as taking the square root of the numerator, which is going to be this 2 minus the square root of 3, right? Over a square root of the denominator. But the square root of 4 is just 2, right? 2. Now, Professor, what do I do with this plus minus? Well, go back to the original problem here. They are asking you to compute sine of 15 degrees, right? This 15 degrees is in quadrant 2, right? Quadrant, sorry, 1. In quadrant 1, right? The first quadrant, 15 degrees in quadrant 1, right? So therefore, it means that this sine of 15 degrees, 2 into 30, 15, right? Should be positive, right? Should be positive. So you just ignore the negative one and you say, okay, this is just this, right? Square root of 2 minus the square root of 3 over 2. And that's it. That's it. You see, let me comment on the form here. You see a big radical here inside the number 2 minus a small radical here, okay? This is what mathematicians call a nested radical, nested radical. And I'll write it here for you, right? Nested radical. Right? And it's very common when you compute the trigonometric function of half of an angle, okay? Now, sometimes you may have the other form, there is a square root of something plus a square root of something, right? This can be converted to the other form. In value, they are the same, okay? So, but don't be surprised when you deal with half an angle, you very often you will encounter these nested radicals, okay? So don't be afraid, it's just that. All right, so that should be the answer, right? That should be the answer. Yeah, or let me show you first, right? And then you can do the one with cosine. Let me show you how to get in exact form this sine of 22.5 degrees. And then I will ask you to do the one for cosine, okay? All right, great. So let's say we want to do this. Sine of 22.5 degrees. Notice, when you divide the angle 45 degrees by 2, you get precisely this 22.5 degrees, right? It's the half of 45 degree angle. So therefore, I can see this as sine of 45 degrees divided by 2, right? So I can apply my half angle formula. But now I know that applying the half angle formula for sine, this is equal to 1 minus cosine of the angle here, 45 degrees, divided by 2, right? Divided by 2. That's what it is using the half angle formula. Maybe I should write here, recall cosine, sine, right? So sine here of half of an angle, alpha over 2, is equal to plus minus the square root of 1 minus cosine of alpha over 2. This is what I have used here for alpha equal 45 degrees, right? You can see. Very good. And this is also, this formula is also in our sheets, in the unit circle sheet, right? You can get it from there. All right, but now let's work it out, right? And to work it out, remember, you have to do a lot of algebra here. Cosine of 45 degrees, what is that? Cosine of 45 degrees is a square root of 2 over 2, right? Square root of 2 over 2. I have memorized this result because I'm using it a lot, but in case you need to confirm, remember the unit circle has that information. 45 degrees is here, right? You just look at the first coordinate, right? 45 degrees here is this guy, 45 degrees. Square root of 2 over 2, cosine here, sine here, right? Very good. That's it. Okay, next I have to do the algebra here, right? The algebra. Remember, 1 is the same as 1 over 1. Let's write it. 1 over 1. But then LCD of 1 and 2 is 2. Multiplying this by 2, multiplying this by 2, I'm going to get the following. That is equal to plus minus 2 minus a square root of 2 on the top divided by common denominator 2, all that divided by the number 2. All that divided by the number 2, right? But now, remember guys, this number 2 is the same as 2 over 1. So I am dividing this fraction by this other fraction. So that is equivalent to multiply this fraction on the top times the reciprocal of this fraction on the bottom, right? So let's do it here. So equal to plus minus square root of 2 minus square root of 2 over 2 times 1/2, which is the reciprocal of 2, right? 2 times 2, 4. The bottom 4 on the top, 1 times 2 minus the square root of 2 is 2 minus the square root of 2. All right, then guys, just take square roots of the numerator, take square root of the denominator, and you will get this, right? A square root of 2 minus a square root of 2, a nested radical on the top, on the bottom a square root of 4. But a square root of 4 is just 2, right? 2. Now, what to do with the sign? Again, pay attention to this, right? 22.5, this angle, 22.5 degrees is in Q1, quadrant 1, right? So this has to be positive. So therefore, you erase, right? Erase the negative 1, and this stays positive. So let's erase it here. That's it, right? This is your answer. So now mathematicians write this equivalently this way: 1/2 of 2 minus the square root of 2. Same, right? So just look for that here. Is here. Excellent. Number 5. Following this, guys, can you try number 6? Try to do this. I am going to give you the formula, okay? Hint again. This guy, 22.5 degrees is 45 degrees divided by 2. And another hint is that cosine of alpha over 2 is equal to plus minus square root of 1 minus cosine of alpha over 2. This is plus here, plus, not minus, plus. Minus is for sine. This is for cosine plus. Use this formula, guys, and follow what I did there. You should end up with something similar, right? With something similar. Try to do that. Yeah, let's write what we have to do here. Okay, if you complete it, let me know. Aha, I see on the chat some activity. Yeah, Gabriela, let me double check Gabriela here. Excellent, excellent, Gabriela, excellent. Very good, well done. Very good, very good. Okay, great. Excellent, excellent. So if we write this out, right, this should be the square plus minus the square root of 1 plus cosine of 45 degrees over 2, right? Over 2. But notice that this, except for the minus, is the same as we did here, right? Same as we did here. Exactly the same. So we're going to end up with this guy, but with a plus here. Excellent, excellent. Right? Due to the similarity. So this will be 1/2 of square root 2 plus square root of 2, this nested radical, right? This nested radical. So we're talking about this guy, right? Excellent, excellent. Very good, very good. All right, let me explain now what to do for some other forms. For example, what to do if they ask you to simplify this, number 7. I'm going to show you, okay? Sometimes they might ask you for some simplifications, and then I will do also, we'll do together number 8. Suppose they say simplify this, right? Simplify 1 minus 2 times sine square of x over 2. Notice the expression contains the sine of half of an angle, right? So we gotta recall that sine of alpha over 2 is equal to plus minus the square root of 1 minus cosine of alpha over 2, right? We're going to recall that. We're going to do that here, and we will say that this should be equal then to the following. The square of this, right? The square of this plus minus square root of 1 minus cosine of alpha over 2, all is squared, right? And putting this in here, maybe. Yeah, great. Now, the good thing about squaring something is plus or minus is that the result should be positive, right? Should be plus. And not only that, the 2 as exponent will cancel the radical part, right? The radical part. So we will be free from the radical part. 2 times 1 minus cosine of alpha over 2. Now, notice this number 2 on the top, this number 2 on the bottom, they cancel. We end up with this 1 minus cosine of alpha. But what is that? 1 minus 1, when you distribute the sign, minus times minus, minus 1, minus and minus plus cosine of alpha. 1 minus 1, 0. Believe it or not, guys, all this ends up being just cosine of alpha. Which should be the answer, right? It should be the answer, cosine of alpha. Okay, so this is this number 7. Very good. Let's try to do now number 8 together. Okay, I will give you a hint. If you cannot do it, I will do it. I will show you how to deal with this. It says find cosine of theta given the sine of theta over 2 equal to this. So they're giving you this information, right? They're saying that sine of theta over 2 is equal to 5 over 8. Figure out what is cosine of theta, right? So going in reverse, right? In reverse. So hint. Notice that sine of theta over 2 has a formula, right? Is this plus or minus the square root of 1 minus cosine of theta over 2, right? One hint should be replace this here and solve for cosine of theta, right? What they're asking you to do. I will give you some time for you to do this, and then we will do it together, okay? Yeah, try this and try to figure out if you can solve this. Basically, we have to, don't forget this, right? Yeah, we have to solve this equation for cosine of theta. Yeah, try this. Over 2. Solve for cosine of theta by squaring both sides. So squaring both sides. Both sides. Square both sides and then get rid of the radical, get rid of the plus minus, and then solve for cosine of theta. Yes, a little tricky, this problem. A little bit long, but let's do it. I think it will help you in your homework and also on the exams. Third exam and final exam, right? Yeah, great. Okay, let's do it together, okay, together, and then so we can start with a review. Okay, great. So here I have to square both sides, right? This plus minus 1 minus cosine of theta over 2 equal 5 over 8. I'm going to square both sides to get rid of this plus minus, right? Squaring will eliminate the square root because the square root and squaring are inverse functions of each other, right? So, and also it will eliminate this plus minus. It will output just a positive quantity, right? So this will be 1 minus cosine of theta over 2 equal to 5 squared, 25, 8 squared, 64, right? 64. Very good. Now, once you are here, when you have two fractions equal to each other, a good technique is to cross multiply, right? Cross multiply. There are other techniques. You may follow any technique you want, but I am going to cross multiply. Times this should be equal to this cross product, okay? So 64 multiplied by 1 minus cosine of theta should be equal to 2 times 25. Let's do the math here. 64 here minus 64 cosine of theta equal 2 times 25. That is 50, right? That is 50. Very good, very good. Now we want to isolate this guy. So I'm going to subtract 64 of both sides of this equation. Here 0, here minus 64 cosine of theta equal this difference. This difference is just minus 14, right? Minus 14, you can get it with the calculator. Okay, so now dividing both sides of this equation by this number, negative 64, we will isolate cosine of theta, right? Minus 64 here, minus 64 here. Cosine of theta equal, eliminating the signs, this is just 14 over 64. Simplifying, dividing by 2 both, cosine of theta ended up being just 7/32, right? 7/32. Very good, guys. And then you look through the choices, and it should appear there. Yeah. Excellent. Very good. So you may say, Professor, you didn't use this information. Yeah, we didn't need to know that the angle is on the first quadrant, right? But sometimes, as you saw before in some examples, you may have to figure out where the angle is in order to determine the sign, but not here because we were squaring both sides. Positive or negative, when a square becomes positive, right? So it was not needed. So great. All right, let's go now, I think, guys, to the review, because with this we have completed half angle formulas. So let's start with a review, okay? Let's go to the review for exam 3. Have it here. So if we start now, then we continue on Wednesday. So it will be easier. All right, let's start with this question. Review for exam 3. Find a positive and a negative angle that are coterminal to the given angle, okay, to the given angle 53. So try to do, guys, this first question and tell me if you can figure out the answer. Try to figure out two coterminal angles, one that is positive and one that is negative. And let me remind you, right, in order to find coterminal angles that are positive, you have to add 360 degrees. In order to find angles that are coterminal to a given angle, if you want them to be negative, subtracting 360 degrees should help, right? So yeah, try to do that, and then we will go over number 1. Let's write the hint here. Very good, very good. I see the chat. Okay, great. Yeah, very good, Gabriela, very good. Yeah, it's okay, it's okay. All right, so let's do it together, okay? Yeah, 53 plus, in order to get the positive angle here, positive coterminal angle, right? Coterminal angle. We add 360 degrees, right? If you add 53 plus 360 degrees, take your scientific calculator, do this. 413, okay? 413. That should be the positive coterminal angle. For the negative coterminal angle, should be the following, right? 53 minus 360, negative 307 degrees, right? Negative, let's write it here so you guys can follow when you're studying for your, when you're preparing for your exam 3, negative coterminal angle, right? So 307 degrees negative. All right, so we choose this, right? Follow, guys? Great. Let's go over number 2. Number 2, the same. They're asking you to generate a coterminal angle that is positive for negative 41 degrees and a coterminal angle that is negative. We will follow the same strategy, right, as before. We take our angle, we add 360, and this hopefully will give us the positive coterminal angle. Remember, 360 degrees represents a full round, right? Full round. So trigonometrically speaking, it's not changing the angle, right? So that's why we allow ourselves to add or subtract 360 degrees in order to get our coterminal angle. So adding 360 degrees to negative 41 degrees, 319 degrees, right? 319. So that will be this guy, 319. Now I want a negative coterminal angle. So instead of adding 360 degrees, I subtract 360 degrees, right? So let's see what we're gonna get when we subtract 360 degrees. We get negative 401 degrees, right? Negative 401 degrees. Okay, so this should be then this choice, right? Mm-hmm. Very good, guys. Now, also we will go over conversions, okay? You should be able to convert from degrees to radians and also from radians to degrees, right? So this problem is asking you to get the coterminal angles. So in case you don't feel comfortable working here with this angle in radians, pi over 6, right? You should convert it to degrees, and that shouldn't be a problem. Now, how do I know that this is in radians? Well, because I don't have this little hollow circle on the top, right? No units means radians. It's a mathematical agreement, right? Very good. But however, I'm gonna just do it in radians. How? Well, we said, right, in order to get a positive coterminal angle, I simply add 360 degrees, but 360 degrees in radians is just 2 pi radians, right? So you add 2 pi. Do it. Notice 2 has denominator 1 here, LCD 6, which means that we have to multiply this guy by 6, this guy by 6. So we're gonna get here pi over 6 plus 12 pi over 6, right? Which is just equal to invisible 1 here, 1 pi plus 12 pi, 13 pi over 6. This is the positive coterminal angle, right? Great. For the negative coterminal angle, you do something similar, but instead of adding 2 pi radians, you subtract 2 pi radians, right? Notice here, denominator 1, LCD again, 6, right? So we have pi over 6 minus 2 pi times 6, 12 pi over 6. And if you do the math here now, look, 1 minus 12 is minus 11, right? Minus 11. Remember, you take the difference and the dominant in value determines the sign, which is 12, divided by 6. Positive coterminal angle in radians, negative coterminal angle in radians, right? So, which is this guy, number 3. You follow, guys? Yeah, any questions, just let me know. Let's continue. Now conversions, right? As I announced before, convert 90 degrees to radians. All right, so remember, for conversions, we have a method, right? If you are going from degrees to radians, we said you should multiply by this conversion factor. 180 degrees on the bottom to eliminate degrees. It's equivalent in radians, pi radians on the top, right? Pi radians here. But what is this equal to? Well, notice the degrees are canceled. And I end up with this 90 pi over 180. And this is in radians, right? Radians. Now, mathematicians have this agreement: when an angle is expressed in radians, you don't have to write this unit radians, right? You just drop it. So this will be the answer, but let's be nice, let's simplify, right? I can divide this by 90 here. I can divide this by 90 here. So I'm gonna get pi over 2, right? Pi over 2 radians. That's it. This, right? Another conversion from degrees to radians. This is a negative angle, right? Negative 60 degrees now. We're going to multiply this negative 60 degrees by this conversion factor, right? 180 degrees on the bottom. You may say, why you write that in the bottom, Professor? Well, to eliminate degrees and to output just radians, right? Pi radians, it's equivalent on the top. Very good. So we will get minus 60 pi over 180 radians, right? Radians, but remember, I can drop this radians, right? It's a mathematical agreement. It is understood that what I will get is in radians. Now, let's be nice. Let's simplify. I'm going to divide numerator by 60, denominator by 60. So I should get here 1. I don't have to write a 1. This is pi over 3. Minus pi over 3, which is this guy, right? Very good. Moving on, another conversion, this one from degrees to radians. So start by writing out 810 degrees, right? Multiply by your conversion factor, 180 degrees on the bottom, pi radians on the top. Do the math here. Notice the degrees cancel with the degrees here. I end up with 810 pi over 180. Now let's simplify. Radians, I don't have to write radians, right? We know it's going to be radians. Now let's simplify. Divided by 10, we get to cancel the zeros, right? I end up with 81 by 18 pi. Divided by 9, you may do this simplification gradually, right? 9 pi over 2, okay? And after that, I can no longer simplify, so this should be it, right? 9 pi over 2. Yeah. Number 6. Very good, guys. Moving on. 7. Convert the angle from radian measure to degree measure. The opposite, right? Round to the nearest hundredth of a degree when appropriate. All right, so here we have 9 pi over 2 radians. You may say, Professor, how do you know this is in radians? Well, because there is a mathematical agreement. When the units are not shown, it means that it's in radians, implicitly, right? Understood that it's in radians, so radians. Now, I'm going to multiply this by a conversion factor. But now the conversion factor has to have on the denominator pi radians, because I want to eliminate radians, right? And on the top, it's equivalent, 180 degrees, because I want to output degrees, right? So radians cancel with radians. Also, you see that pi cancels with pi, and I end up with this 9 times 180 degrees over 2. But what's that? Well, just put it in your calculator, right? And do the rounding if needed, as indicated, right? Over 2. 810, right? 810. So very good, guys. 810 here. Degrees. This guy, right? For number 7. Excellent. Moving on. Another one. Minus pi over 3 radians converted to degrees. Multiply by your conversion factor, right? Pi radians on the bottom, 180 degrees on the top. Notice radians will be canceled with radians. Pi will be canceled with pi. There is just 1 left here. 1 times 180 degrees is 180 degrees over 3. Don't forget the negative sign, right? And this is just 3 into 18 is 6. So attach a 0, negative 60 degrees, right? Very good, guys. Another one here, 9 pi over 4. 9 pi over 4 radians converted to degrees. Well, multiply by your conversion factor, pi radians on the bottom, 180 degrees on the top. radians, cancel with radians, pi, cancel with pi. What is left? 9 times 180 degrees over 4, right? Well, what is that? Well, let's put it in our scientific calculator or in our Desmo scientific calculator. I strongly recommend you to use, guys, is OER material free. 405, 405 degrees. This guy, number 9. Very good. Moving on. Now, this deals with complementary angles and supplementary angles. It says find the complementary angle to theta equals 68.3 degrees. Recall, theta and 90 degrees minus theta are complementary angles, right? Based on that, there is sort of a formula to generate complementary angles when an angle is given, and it's this 90 degrees minus the angle that they give you, right? 30 degrees. There we go. Very good. So now, what is this? Take your calculator. Do 90 minus 68.3. That is 21.7, right? 21.7 degrees. 21.7 degrees. And that is what you have here, right? Complementary angles. The sum of these two angles is 90 degrees, right? They complement each other to add up 90 degrees. Great. Supplementary angle. For supplementary angle, you must recall that theta and 180 degrees minus theta are supplementary angles, right? So again, we can use this as a formula to generate supplementary angles when an angle is given, right? So 180 minus theta, theta is 112 degrees. Let's do the math there. So 180 degrees minus 112, 68 degrees, right? 68 degrees, great, 68 degrees here. This guy, right? For 11. Moving on. Now we get to some applications of angles measured in radians, right? The first one is a formula that allows you to compute the arc length, right? The arc length. Use the formula S equal R theta. Arc length is S, right? R theta, meaning this distance, right? This length, the length of this arc. Based on this given figure, right? They're showing you an angle of pi over 3 radians, right? And a radius of 16 inches. So clearly S has to be equal to what? Radius 16 inches, right? Times the angle. The angle is in radians, so I don't have to convert it to radians, right? Because this formula, remember, works, theta is in radians, right? But we got lucky. The angle is in radians, so all we gotta do is just this, right? It's computation. So let's do it together. And they say round your answer to 2 decimal places. Let's keep that in mind. All right, so we gotta do 16 times pi over 3, right? I just type pi for pi, but you can get it from here too if you want to. It's the same. And then the answer is going to be this 16.75, but because of this 5, since I'm rounding to 2 decimal places, it will be 16.76, right? 16.76. 16.76. In the end, feel free to attach the units inches, right? 16.76 inches, which is this guy, right? Very good. Excellent. Now, continue with number 13. Number 13 deals with, again, arc length formula, S equal R theta, where theta is in radians, right? Don't forget that. All right, S equal R. In this case, the radius is equal to 6 inches, 6 times theta. But theta, recall, must be in radians. It's not, right? It's in degrees. It's 135 degrees. But no problem, because we know how to convert this guy to radians, right? To radians. So we're going to do it. To convert to radians, simply we multiply 135 degrees by this conversion factor, 180 degrees on the bottom, pi radians on the top, right? I don't have to write radians. So this is it. This is all you got to do to compute the arc length. So let's do it in our calculator, and let's round this to 2 decimal places as indicated, right? So 6 times. Notice how I'm using just parentheses, and I don't have to type the multiplication symbol, right? Times pi. Yeah, now I think I need it. Pi, you can take it from here or write pi, it's the same, divided by 180 degrees. So this gives you 14.137. Because of the 7, when you round these to 2 decimal places, this will be 14.14, right? 14.14. 14.14. In the end, attach the units. We're dealing with the length, the arc length, right? So just inches. That's it. This guy, number 13. 14, let's go over 14. Second application of measuring angles in radians is about figuring out the area of a sector, right? The area of a sector. So the formula for that is this: area of a sector is equal to 1/2 R I think it's our theta times R squared times theta, right? Where theta is in radians again, right? Where theta is in radians. If you have not memorized this formula, write it down, have it handy, right? We're gonna need it, right? It's a very important formula. All right, so let's do the computation. This will be 1/2 times radius. The radius is 25 meters squared times theta in radians. Theta, fortunately, is in radians already, right? So just put it in here, right? And do this computation. Area equal, let's take the calculator. You do 1/2 times parentheses, right? 25 squared. You may use this, or you may use shift 6, right? To place the square there. Times 2 pi over 3, right? Yeah, use your scientific calculator. I get 654.49, but this 9 becomes a 10, this 4 becomes a 5. So 654.5, right? 654.5, which is here, right? Let's write it down. 654.5. In the end, feel free to attach the units. We are dealing with area now, so the unit should be square. So 654.5 square meters, right? Square meters. So it's this guy, number 14. Square meters. Great. Now let's go to number 15. Find the area of the shaded sector round to 1 decimal place now. Okay. All right, so again, right, area equal 1/2 R squared theta where theta is in radians. Don't forget. Okay, then area will be equal to 1/2 times r. R is 13 feet, so r squared, 13 squared, times theta. Theta is 20 degrees. It's not in radians, right? Not a problem because you can convert this to radians. 180 degrees on the bottom, pi radians on the top, right? Yeah, great. So compute this and round it to 1 decimal place. Okay, let's follow that. So we're gonna have 1/2 times 13 squared times 20 times pi over 180, right? 29.5 rounded to 1 decimal place, right? 29.5. And in the end, let's attach the units. I'm dealing with feet, so the area should come out in square feet, right? Square feet. Very good. This is it. So should be this. 415. Excellent. Very good, guys. Now, let's talk about these other forms. It says use the given trigonometric function value of theta to find the requested trigonometric function value of the acute angle theta. Rationalize the denominator where necessary. Okay. They're saying here acute angle, right? Acute angle theta, meaning the angle has a measure between 0 and 90 degrees. The angle can be placed inside a right triangle. So we are talking about right triangle trigonometry here, right? Okay. All right. They are saying that sine of theta is 4/5. They are asking us for tangent of theta. All right. From here, remember from SOHCAHTOA, sine is opposite over hypotenuse, right? Opposite over hypotenuse. So what I'm going to do is I'm going to make up a triangle whose opposite side has this length 4, whose hypotenuse has this length 5. I don't have the base, but I can find the base using the theorem of Pythagoras. Theta can be placed inside, right? It's an acute angle. So from here, b squared plus 4 squared equal 5 squared following the theorem of Pythagoras. B squared plus 16 equal 25. Subtracting 16 both sides, b squared equal 9. Taking square roots, b square root of 9, b equal 3. I found the value of b, put it there, b equal 3, right? We have completed this right triangle. So now we're ready to compute any trigonometric function of theta, right? So now you're looking for tangent. You can find any trigonometric function of theta, in particular tangent. Tangent is going to be opposite 4 over hypotenuse, right? That's it. Very good, guys. Yeah, opposite over adjacent, not hypotenuse. I was still thinking about sign. It's opposite over adjacent, right? Yeah, maybe we should write it here so everybody can follow. Opposite over adjacent. So tangent of theta will be opposite 4 over adjacent 3, right? 4 over 3. This is it. Very good, guys. All right, so this one I think is similar. You can just follow this, right? Similar to 16. I'll write similar to 16. Okay. Instead of tangent, cotangent, right? Follow the same idea. Construct a triangle, work with it. 18 is more interesting because it deals with simplifying trigonometric expressions using identities, right? Trigonometric identities. So they say simplify this. Cosine of theta. Well, it is a good strategy to write tangent as sine over cosine, right? Tangent is sine of theta over cosine of theta. This comes from the quotient identities, right? Quotient identities. And cotangent is cosine of theta over sine of theta, right? Cosine of theta, same as cosine of theta. Just leave it alone. Then when you distribute your multiplication here, you're going to get the following: sine of theta over cosine of theta times cosine of theta over sine of theta minus sine of theta over cosine of theta times cosine of theta. Eliminate these guys, eliminate these guys. This is just 1, right? 1. Not 0, 1. Okay, be careful there. This cancels with this, sine of theta. So 1 minus sine of theta, right? This is what is left after simplifying. So this guy, right? Very good, very good. Moving on. There's another one. Yeah, I think we still have time for this one. Tangent of theta over secant of theta. What is this equal to once we simplify? Remember, the strategy is when you see sine, write it as, when you see tangent, sorry, write it as sine over cosine, right? It's a good strategy. When you see secant, use the reciprocal identities, right? Write it as 1 over cosine, right? 1 over cosine. Great. But now, what is this? Remember, when you divide a fraction by another fraction, you just multiply the fraction on the top by the reciprocal of the fraction on the bottom, right? So what we're going to do next, the reciprocal of this guy is cosine of theta over 1, right? Now notice cosine on the top, on the bottom, they cancel. Sine of theta over 1 is left, but sine of theta over 1 is just sine of theta, right? That's it. Very good. Yeah, let's do this number 20. Simplify cosine of theta multiplied by tangent of theta. Again, when you see tangent of theta, think of the quotient identity. Tangent is the same as sine over cosine, right? So sine of theta divided by cosine of theta, eliminating cosine, final answer sine, just sine of theta, right? So this guy, 20. Very good. Let's see number 21. It says use fundamental identities to simplify the expression. Okay. So we have sine square of theta plus tangent square of theta plus cosine square of theta. What I'm going to do first here is this. I'm going to rearrange the terms of this expression. Remember, the order of the addends does not change the sum, so I can always rearrange the addends, right? Cosine square here, tangent square here, and you may say, Professor, why are you doing this? Well, because recall, sine square of theta plus cosine square of theta, according to the Pythagorean identity, is just 1, right? 1. So my intention is to replace this with a 1. 1 plus tangent square of theta. Okay. But also recall, there is this other Pythagorean identity that says that 1 plus tangent square of theta equals secant square of theta, right? And you may say, Professor, where can I find this identity? Well, if you don't know them by heart, you can look at the unit circle sheet. They are there. Here. Look, this one says sine square plus cosine square equal 1. 1 plus tangent square equals secant square, right? And 1 plus cotangent square equal cosecant square. Okay, they are there in the unit circle sheet. All right, great. So then this becomes just secant square, right? Of theta. over theta, which is this. Very good, guys. Yeah, I think we can do this one too, number 22. Let's check. Cosine square of theta over sine square of theta plus cosecant of theta multiplied by sine of theta. Here, let's do this trick. Cosine of theta, sine of theta kind of resembles cotangent, right? So what I'm gonna do is I'm gonna rewrite this algebraically. This is the same as this, right? Cosine of theta over sine of theta is square plus here. This other part, for this other part, I use the reciprocal identities. Cosecant is 1 over sine. So 1 over sine of theta here times sine of theta. Bit tricky, this one. Look, cosine of theta over sine of theta is cotangent of theta, right? Square plus sine of theta times 1 sine of theta divided by sine of theta is just 1. So what do I have here? I have cotangent square of theta plus 1. But what is cotangent square of theta plus 1? Well, this is just cosecant square of theta, right? Professor, where did you get this from? It's a Pythagorean identity. Again, guys, it's here in the unit circle sheet. 1 plus cotangent square. You can see that, right? 1 plus cotangent square equal cosecant square, right? Very good. All right, so we're talking about this guy, right? Number 22. All right, now this 123, I think, could be the last one, or one of the last ones. Let's see. Here is sine of theta times cosine of theta over tangent of theta, right? Remember, rewrite tangent of theta as sine of theta over cosine of theta. It's a good strategy, right? I strongly recommend you to do that when you see tangent. Or when you see cotangent, you write this cosine over sine, right? Yeah, very good. But now, I'm dividing this quantity by a fraction. That is the same as multiplying the quantity by the reciprocal of this fraction, right? Cosine of theta over sine of theta. Now, these two guys cancel. Cosine times cosine is just cosine squared, right? Cosine of theta squared. But mathematicians write this as follows. Cosine, they place the square in the middle, cosine square of theta. So this should be this, right? Number 23. Then they are checking here on your knowledge about computing these guys using the scientific calculator and rounding it, right? Yeah, let me show you quickly this. Sine of 42 degrees, how you get it in the calculator. And once you get it, you should round it to 2 decimal places, okay? Let's do it. So you bring out your scientific calculator. I strongly recommend you to use this Desmo scientific calculator. You go to functions, look for sine. Sine is there, right? And then you're gonna write inside parentheses here 42 degrees. But now be careful here. By default, this is giving you in the computation in degrees, right? So it's this guy then, right? Because we wanted this degree, but in case they want this in radians, you have to switch it to radians, right? Yeah, you know that. All right, 0.669 rounded to decimal places, 0.67. 0.67, that's it. 0.67. Right? 24, 25. This one's similar, right? Tangent also similar, right? You do this the same, but probably I should show you what to do when this happens. Yeah. Cosine of 2 pi over 5. This angle, you don't see the hollow circle on the top, is in radians, right? You say, Professor, how do you know? Because when they don't have the units, it means that it's in radians. So you gotta do this in radians. So when you do the computation in the calculator, guys, just be careful that functions, cosine 2 pi over 5. By default, this is going to give you the answer in considering that this is in degrees, but this is not the right one, right? Right? And if you round it, probably you could get this, but this is not the right answer because you have to switch it to radian. Radian. Now this is the right answer, 0.3, right? 309. They want you to round it to 2 decimal places, so 0.31, right? 0.31. Very good. 0.31. This, right? It's tricky, guys. Be careful there, right? Yeah, I think with this we have enough.